as a rail, while we are calling this as a rung. This is called rail, while the other one is called rung. In ladder, in real life situation also, this is called rung. While rail, we call it, the rail line. When if you see the rail line, they will have a two rail, parallel rail that going, and the train will actually move through this. And there is also a rung in each of the rail that the foundation of the rail, you can say. So this is also can be called as a rung. So that's why now we need to understand what is the purpose of rail or rung. So rung, the purpose of rung is to write ladder logic. One simple representation is you have a logic that you can write in one of the rung. Okay, and then to extend some more logic, you can write logic in another rung. That means it is equivalent to writing a line of code in ladder logic editor. So this is line 1, you can say this is line 1 and this is line 2, and it will continue in the ladder logic. So for example, in Rockwell automation, if you see on the left side you have the number. So when you actually insert more rung like this, and you get another rung, and you can do ladder logic programming to this new rung. So this is kind of a line of instruction, just like you write code in any other language. You'll have a line that separated by semicolon in many languages like C, C++ or Java. But some programming language, they don't have any specific division between two instructions. Instead they have line break, just like Python has line break, a specific formatting to know that it's in different line. But in PLC ladder logic, we have this arrangement to differentiate between two lines of code by rung. So rung 0 is one line of code, rung 2 is another line of code, and so forth. You can have that hundreds of rungs in each program, and it defined by the manufacturer of the PLC. So software will have some limitation how many rungs you can write in each of the subroutine. Okay, so you have to find out, we will find that how many runs of code you can write. Sometimes it is depends on the memory of the PLC. Now on the rail, what is that rail? The purpose of rail is to actually equivalent to the electrical terminologies, positive line and negative line. So for example, you have ladder logic, this one. So you can actually define this is 24 volt plus, and this is 0 volt. It's like phase and neutral. Okay, so you have power going on from left to right. Getting your point? Left to right. And then your program will be scanned by PLC from top to bottom. So you have two directions to understand that your scanning goes from top to bottom and left to right. So First, the programmer will scan the first rung, and then it will scan the second rung, and so on and so forth until the end reaches. So if some what is called subroutine come in between one of the rung, then the PLC will open this subroutine, and inside that subroutine it will, let's say this is your subroutine, and inside we'll have again that rung arrangement, and it will have the same logical arrangement of rungs like rung 1 2 3 4 so forth. So in that subroutine, when all the scanning is finished, it has to return, it will scan from top to bottom and left to right. So it will read one rung at a time from left to right, and then next run, and up to the end. And when the end reaches, it will come back here and assign the output, move the output, and go to the next instruction if anything is there, and then again it will jump to the next instruction. So this is how the ladder logic is scanned, read in the PLC program. Now, few things to note. You now got the understanding of what is rail and what is rung, and there is one thing to understand: each ladder instruction has some input and output. For example, this is called instruction, or it is actually checking for on. So it will have a tagged name or variable name assigned to it. So that is kind of input, and also the rail, the positive side on the left side of the rails is the positive voltage. This is also considered an input. So if it is positive, that means it's giving 1. If tag has 1, then actually this is 1 and 1. If it is in series, obviously it is in first. If it is first element, it is always in series. So 1 and 1, it will result in output as 1. And then if another instruction, for example coil is there, is taking input, so this 1 will be assigned in coil, and the result will be 1 for this. If it is for lamp, then lamp will be turned on. So now you see in one rung you will have minimum two elements, some inputs and some output. Here you have two input. Obviously this one we considered as an input as well. This is default input. When you have any instruction in a rung, the first input is your rail, and the second input is the instruction tag is given to the instruction. So this is tag is another input, and the output here is the coil, and the coil will have some tag. The tag is here, the coil tag, you can say, as the output. The instruction itself is the output instruction because it has to be used on the right side. All the output must be used on either right side or after executing some input calculations. So you have now input, some inputs and some output. You don't worry about the details, we'll come across in the later section. So just what are the main elements required in the ladder logic that I'm telling. Now logical expressions are the another one. When we have multiple element in ladder logic, you have logical expression that you need to define or determine the result of that logical expression. Here you have logical expression of two instruction that is in series called AND, and then the result of this AND operation, this is X, this is Y, and if it is Z, the X and Y is the output assigned to Z. And in ladder logic, you will have some place for comments, just like any other language. You will have some comments written in ladder logic. So some are written just above the ladder logic. Here maybe, just like if you see here in Rockwell Automation Studio 5000, you have this section. You can write multi-line instruction, comments in this section. This is called rung comments. You will have comment in each of the tag as well. If you go here and edit the strut properties, you have this description section for each of the tag or variable. Here you can put the comments. Now, address notation and tag names are determined and defined in standard PLC software, and there is one standard IEC. Let me show you the name, IEC 61131-3, and it is a standard that standardize the PLC programming software. So PLC tags used must be in such that it can indicate some process variable, process name, or unit or object name, so that programmer can get understand, or any user who will troubleshoot the system will understand easily. Like any other language, we should use comments and name of the variable in such a way that it aligned with the process. So in Rockwell Automation don't use the addressing system for the Studio 5000, but they used to have that in RS Logix 500, SLC and Micrologix PLC. They used to have tag as well as the address for the tag. I think we can come to that later in another session, but that logic, we write ladder logic right, we can have a tag name here and the address as well, address for the tag of the tag. Sometimes in software there is feature that you can actually enable just to show the tag, or just to show the address, or show display both. That's possible. That's the part of the software feature. And this is all of that, the seven thing in the ladder logic. One is the rail, rung, and then input, output, logical expression. This is important. Expression, and then tag name and address, plus comments. And if you got used to all of these, you are good to start with the ladder logic. Rail, rung, input, output, logic, logical expression, tag name and tag address, and then comment. This 7 thing and you're good to start.